Hi, my name is Magnar Nordahl. I'm a captain and instructor on ATR 42 and 72 aircraft. And in this video, I will talk about the fuel system. The fuel is stored in two tanks, one in each wing. The fuel tanks are part of the wing structure. ATR 42 has a fuel capacity of 2,250 kilos in each tank, total 4,500 kilos. ATR 72 has a fuel capacity of 2,500 kilos in each tank, total 5,000 kilos. Each tank is divided into three parts: the main tank, the feeder tank or feeder compartment, and the vent surge tank. Most of the fuel is stored in the main tank. When the tank is full, it has enough space to allow for 2% thermal expansion without spillage. A rib with holes divides the main tank into two parts. This dampens lateral movements of the fuel in flight. The inner part of the main tank has two water drain valves. The feeder tank has a volume of 200 liters and holds 160 kilos of fuel. During normal operation, it is always full. This ensures that the fuel supply to the engine is not interrupted by negative or lateral load factors. The vent surge tank does normally not contain fuel. It is part of the ventilation system. The ventilation system ensures positive air pressure in the fuel tanks. The vent surge tank has a volume of 100 liters and is connected to the atmosphere via a NACA inlet under the wing. A ventilation duct and a float valve connect the vent surge tank with the main tank. The ventilation duct ensures a free flow of air out of the main tank during refueling and into the tank when the fuel is consumed. The vent surge tank also serves as a reservoir in case of thermal expansion of the fuel or accidental spillage during refueling. When fuel is consumed during flight, any fuel left in the vent surge tank is returned to the main tank. The manuals do not explain how this happens, but I assume it's achieved with a differential pressure. The vent surge tank also has a water drain valve. The wing center box contains fuel crossfeed and refueling lines. It is ventilated to prevent against accumulation of fuel and fumes in case of a leak. The air intake is on the left side of the box, and there are two outlets, one at each side. In each feeder tank, there is an electrical fuel pump. When the electrical pump is operating, it supplies fuel to a jet pump that sucks fuel from the main tank into the feeder tank. A jet pump is a venturi. When fuel flows through it, the velocity of the fuel increases, and therefore the static pressure decreases. The same happens when you squeeze a water hose. You can see the water increase the speed. This creates a suction that pulls fuel from the main tank into the feeder tank. An airbrush uses the same principle. This ensures that the feeder tank is full at all times. Furthermore, the electrical pump sends fuel via low pressure valve, LP valve, to the engine's high pressure fuel pump. Then the fuel enters the fuel controller, which is called a hydromechanical unit, HMU. Here, fuel is metered and sent to the engine. Excess fuel is returned to the feeder tank via a motive flow valve. It's marked with a MF valve. In the feeder tank, the fuel flows through a second jet pump, the engine jet pump. Here, fuel is added and sent to the engine and the feeder jet pump. When the engine jet pump is operating, the electrical pump is no longer needed and stops automatically. A crossfeed valve allows for one tank to supply the engine on the other side. But note, the crossfeed valve cannot be used to transfer fuel from one tank to another. When the fuel pumps are not operating, the feeder tank is supplied from the main tank by flap valves. ATR variants with EFIS cockpit have fuel quantity indicators and fuel flow and fuel used indicators on the central instrument panel. In a glass cockpit, the indications are on the MFD and the EWD. On the MFD engine secondary page, we have fuel quantity and fuel flow indications. On the EWD, we have fuel used indicators and fuel on board, FOB. The latter value, FOB, is independent of the fuel quantity indicators and is entered into the MCDU. Before departure and regularly during flight, you check that both indications agree. Fuel used is reset before each takeoff. In an EFIS cockpit, you pull a knob on the indicator. In a glass cockpit, you use the EFIS control panel and access the performance takeoff data page. The fuel control panel is located on the overhead panel. The low pressure light is illuminated and an alert is triggered when the pressure past the LP valve is less than 4 psi. When the electrical fuel pump is selected off, the multi-flow valve is closed. When the fuel pump is selected on, the fuel pump will run in the following situations: when the engine is not running, and for 30 seconds after engine start, when low fuel level is detected, and when crossfeed is on. When crossfeed is on, there is an indication on the memo panel. The multi-flow valve will open when there is sufficient pressure from the HMU. After engine start, when the pressure from the engine jet pump has been more than 8.5 psi for 30 seconds, the electrical pump will stop automatically. The LP valve is always open until you pull the fire handle. And this indicator shows the temperature in the left feeder tank. Fuel quantity is measured by probes in the fuel tanks. ATR 42 has 5 fuel probes, and ATR 72 has 6 fuel probes. Simply said, a fuel probe is a metal cylinder with a metal tube inside. When an electric current is added between them, a charge field is generated. This is known as capacitance. Air and fuel vapor produces a very weak capacitance. Fuel produces a stronger capacitance. Therefore, a low fuel level produces less capacitance than a high fuel level. The capacitance also depends on the density of the fuel. Below, I have added a link to a video explaining how this works. Signals from the probes are computed and presented as fuel quantity in kilograms or pounds, depending on the configuration of the aircraft. EFIS variants have a separate fuel quantity indicator, and the capacity of each tank is printed above the displays. A test push button is used to test the displays, which should show 8s. A low fuel level alert is triggered when the total fuel quantity is less than 160 kilograms, or when the feeder tank is not full. In the latter case, the fuel indicator will show more than 160 kilos. The fuel quantity can also be measured manually. Under each wing, there are 2 magnetic level indicators. They are made of a rod with gradation marks in centimeters, and they have a magneto at the top. The rod is housed inside a dry cylinder in the tank. Around the cylinder, there is a circular float with a magneto. The procedure is described in FCOM NSU 28.3.4. Here is how to do it. First, you ensure that the pitch attitude is between -3 degrees and +1 degree. You can use the artificial horizon. Open a hatch for the hydraulic reservoir and read aircraft attitude on the inclinometer attached to the airframe. Aircraft bank angle is positive for a wing up and negative for a wing down. On this picture, the left wing is 1 degree down. That means the left wing is -1 and the right wing is +1. Position a platform under the wing root, climb up and use a screwdriver to unlock the indicator rod. Pull the rod down until it clicks to the float. Then you push the rod slightly up and then lower it slowly to the floating level. You note the graduation on the rod which aligns with the wing bottom surface. Push the indicator back up and lock it with a screwdriver. Repeat for the other indicator at the outer section of the main tank. If both indicators do not indicate extreme values, which is 0 to 30 cm for the inner indicator, or 0 to 19 cm for the outer indicator, you can disregard the inclinometer. Fuel quantity is determined thanks to internal and external indicator reading as following. For example, if the inner indicator shows 18 cm and the outer shows 5 cm, you draw a line from those points, and on the graph these two lines meet at 1750 liters. Then we multiply with the specific gravity of the fuel. For example, if the gravity is 0.785 kilos per liter, we have 1,373 kilograms of fuel. If one indicator shows an extreme value, you must disregard this value and use the inclinometer indication and the other indicator value. For example, with a left wing, the outer indicator shows 0. This portion of the tank is then empty. The inner indicator shows 5 centimeters, and the inclinometer is -1 degree. The result is 755 liters. With a specific gravity of 0.785 kilograms per liter, we get 592 kilos. And don't forget to use +1 when you calculate for the right wing. There is a refueling control panel in the forward part of the right-hand landing gear fairing. ATR 42 has a refueling connector in the leading edge of the right wing. This position allows for refueling while the engine is running in hotel mode, which means that the propeller is not turning. ATR 72 has a refueling connector in the aft part of the right-hand landing gear fairing. This position requires the engine to be stopped, but it's more convenient for the handler, who doesn't have to climb up a ladder to the wing. At 50 psi, the aircraft can receive 240 cubic meters per hour. This equals 400 liters per minute, or about 320 kilograms per minute, depending on the specific gravity. On top of each wing, there is a cap for refueling by gravity. The refueling control panel is energized by the ground handling bus when the panel door is open. There are two variants of the panel. This is the control panel used in aircraft with ASPIS cockpit. And I can tell you that this is from an ATR 42 because the panel door is hinged on the top. On ATR 72, the panel door is hinged on the right-hand side. The fuel indicators are identical with the indicators in the cockpit, and they will be energized when the panel door is open, even when the battery switch is off. To refuel, select the total fuel quantity with the pre-selected wheels. Then set the mode selector switch to refuel. That's all. The system will distribute fuel evenly into the tanks. A blue valve light illuminates when the associated refuel valve is open. An amber high-level light illuminates when the associated tank is full. The refuel valve will then close. The light bulbs are tested by pressing on the bulbs. The test button is used to test the fuel quantity indicators, which will show 8s, just like when you test the indicator in the cockpit. During normal operation, the refuel valve switches are set to normal. If the automatic controller is inoperative, the refuel valves can be opened manually by selecting the switch to open. The valve will only close automatically when the tank is full. If that doesn't happen, fuel will enter the vent surge tank. Here there is an overflow sensor that will close the refuel valve. The refuel valves are manually closed by selecting the refuel valve switch to shut. To remove fuel from the tank, you select the refuel valves to shut, set the mode selector to defuel, and select the refuel valves to open. When the desired quantity is reached, select the refuel valves to shut, set the mode selector to off, and then the refuel valves to normal. This switch is for a light in the main landing gear bay. On ATR 72 there is a surge valve switch. It provides ventilation of the fuel line. If there is a vacuum lock in the fuel line during defueling, you set the mode selector switch to off and then open the surge valve for a short moment. ATRs with glass cockpit have a digital refueling panel. The only operational difference is that the selected quantity is set with an increase-decrease switch. Let's have a look at how the system works during normal operations. When the aircraft is powered up, the fuel pumps are off and there is no pressure in the system. The LP valves are open and the multi-flow valves are closed. We will start engine number 2 in hotel mode. First, we select fuel pump number 2 on. We have a green run light and the low feed pressure light goes out. The fuel pump is now feeding the feeder jet pump, which tops up the feeder tank. The multi-flow valve remains closed because there is no pressure in the line. We start the engine. Fuel from the HMU will push the multi-flow valve open. The engine jet pump is activated. It delivers a pressure higher than 8.5 psi. And after 30 seconds, the electrical fuel pump will stop. And the engine jet pump is supplying the feeder jet pump and the engine. We use the same process to start the other engine. In case the fuel load is not balanced, for example after use of hotel mode during a turnaround, you need to crossfeed. First, you select crossfeed on. The fuel pumps will run automatically. Then, on the side with less fuel, select the fuel pump off. This closes the associated multi-flow valve, preventing usage of fuel from that tank. Another reason for asymmetric fuel load might be a fuel leak. A fuel leak is a serious matter. It represents a fire risk, and if you're not able to land within a reasonable time, you might run out of usable fuel. Or the fuel unbalance might exceed the limitation. Maximum fuel unbalance for ATR 42 is 550 kilograms, and for ATR 72 is 730 kilograms. When a fuel leak is confirmed, your first priority is to find a place to land as soon as possible. I have made a scenario where the aircraft departs with 1200 kilograms fuel in each tank, which is a total of 2400 kilos. After half an hour, the aircraft is in cruise and has burned 420 kilograms. Fuel flow is 340 kilograms per hour. Fuel remaining in each tank is 990 kilograms. If you have a leak from a fuel tank, the fuel level in this tank will decrease faster than the rate of the other tank. All of the indications, fuel flow and fuel used, are normal. In an AFIS cockpit, there is no alert. In a glass cockpit, there will be a fuel unbalanced alert when the fuel unbalance exceeds 200 kilograms. There might be a visible spray of fuel from the wing. Now, you have to assess the situation. Check fuel flow and fuel used indications. Check the overhead panel. Call the cabin crew and ask whether they can observe a spray of fuel from the engine or the wing. A visible spray of fuel indicates a very serious leak, but you may not see it when it's dark outside. And also, how fast is the situation developing? In case of a fuel leak from the wing is confirmed, you don't have to shut down the engine yet. However, if the leak is inside the engine nacelle, the risk of fire is serious and you must shut down the engine. Here is a leak between the feeder tank and the high-pressure fuel pump. As you can see, the indications in the cockpit are identical to a leak from the fuel tank. But as I said, the consequences are different. If the cabin crew observes fuel streaming from the nacelle, then there is no doubt. But even there is no visual indication of a fuel leak, it may still be there. Therefore, if you are in doubt, you should shut down the engine. If this leak causes the pressure from the engine jet pump to drop below 5 psi, the electric fuel pump will start to run. This time there is no doubt that the leak is in the engine nacelle. And if the pressure drops below 4 psi, the feed low pressure alert is triggered. This might be a large leak, causing a reduction of fuel flow and engine power. The engine might flame out. Next, we have a leak between the HMU and the multi-flow valve. This will not affect the operation of the engine because the electrical pump will take over from the engine jet pump. The indications are a green run light and a developing fuel unbalance. A fuel leak downstream of the HMU but before the fuel flow meter will result in a fuel unbalance. A serious leak might cause the engine to flame out. Finally, if there is a leak downstream of the fuel flow meter, the fuel flow will increase. Here is the checklist for fuel leak. Land as soon as possible at the nearest suitable airport. Then, if the leak is from the engine, you shut it down. Switch off the fuel pump and pull the fire handle. Those actions close the motor flow valve and the LP valve. Use of crossfeed is restricted to the scenario where you had excessive fuel flow. In all other scenarios, you don't have enough information to determine the exact location of the fuel leak. Therefore, keep the crossfeed closed. That's all for this time. I hope you liked this video so much that you will give it a like and share with your friends. And if you haven't done it yet, please subscribe so you don't miss the next video. Thank you for watching and happy landing!